This is section 4.4, part 3, the final part in section 4.4. We're still looking at trig functions of any angle, and really today we're going to be focusing on what we call reference angles, or the angle of reference. Now, we've been using these throughout the chapter so far without even knowing it. Let's review the definition of a reference angle, and we talked a little bit about this in a previous video. A reference angle is the positive acute angle formed by the terminal or ending side of theta and the x-axis. So it's the acute angle or the little angle that we can use rather than looking at the entire angle. Let's look at a couple examples. Now, the first example is 5 pi over 6 for theta, and we want to know the reference angle we would use. Now, the first thing I'm going to do is draw 5 pi over 6, and 5 pi over 6, hopefully you remember, is somewhere here in quadrant 2. And so this right here would be theta. This would be 5 pi over 6. Now, theta is an obtuse angle, and so it's hard to use a right triangle in terms of this theta because it's more than 90 degrees. So what we're going to do is we're going to take the terminal side and we're going to drop it down to the x-axis, and we're going to create this right triangle inside here. And now the theta in the inside is what we'll use instead, and that's what we call the reference angle. Now, I want to know how much that is. Well, I know that all the way to the x-axis would be pi, or 6 pi over 6. The big angle is 5 pi over 6. So if I subtract 5 pi over 6 from 6 pi over 6, I can see that my leftovers is pi over 6. Now that pi over 6 is what we're going to call the reference angle. The nice thing about these is that the answers for 5 pi over 6 and pi over 6 are all going to be the same. So now instead of using 5 pi over 6, we can just use that pi over 6. This is why we've been drawing those pictures and why the pictures work. Let's look at the next one, 345 degrees. So the first thing we'd want to do is draw that. Now that's getting close to 360 degrees. So that it looks like that theta is going to be the terminal side would be down here in quadrant 4. Now our theta is going to go all the way around to there. That's going to be our theta. We want to know, though, now the reference angle. So once again, we are going to take this and drop it to the x-axis and create a right triangle here. And then our theta is going to be in the inside. Now how much is that is what I want to know. If I take the whole circle, 360, and I subtract that 345 degrees, it looks like I get 15 degrees left. So 15 degrees is now my theta. Negative 135 degrees. Once again, let's go ahead and draw negative 135 degrees. So now we're going in the negative direction. We'll once again start our initial side here. And if I go 135 degrees negative, it looks like we're going to end somewhere in quadrant 3 down there. Now, if I draw this triangle, I'm going to bring my altitude to the x-axis and get my acute angle in the inside here. I want to know how much is left. So really, what I'm going to do right now is I'm going to ignore the fact that we're negative, and I'm going to say all the way around would be 180 degrees. I'm going to subtract 135 degrees, and it looks like I'm left with 45 degrees. That means the reference angle I could use is 45 degrees. Let's try a few more. The next one is 580 degrees. Now 580 degrees is more than one time around the circle. So let's start by finding its coterminal angle. I'm going to take 580 degrees and I'm going to subtract 360. When I do that, I get a total of 220 degrees. So now let's do the same as before. Let's go ahead and draw 220 degrees. 220 degrees is going to end in quadrant 3 down here. And we'll do the same thing as previously. We'll drop our altitude up. We'll actually draw it up and draw in our right triangle here. And now I want to know how much that is. Now, I'm at 220 degrees, and I'm going to subtract 180 because that's the top half of the circle. And it looks like the leftover I get is 40 degrees. So that means my reference angle in this case, right there, would be 40 degrees. Radians, obviously, everything seems a little more difficult when we're in radians because of the fractions, but we'll do the same thing. Now, 1 time around the circle in terms of thirds, 2 pi, is equivalent to 6 pi over 3. So that tells me that 8 pi over 3 is more than 1 time around the circle. So let's go ahead and find a coterminal angle here. We're going to take 8 pi over 3 and subtract that 6 pi over 3. And we end up with 2 pi over 3. So if I draw 2 pi over 3, that's going to be in quadrant 2. We'll go ahead and once again make a right triangle, so we'll drop this down to the x-axis. And we want to know our new theta there. Now in this case, I'm going to take pi halfway around the circle, so pi is 3 pi over 3. And subtract the 2 pi over 3 I've already gone. And I can see what I'm left with is pi over 3. And so pi over 3 is going to be my angle of reference, my theta. And finally, negative 13 pi over 6. Once again, 2 pi in terms of sixth is 12 of them. So let's go ahead and get out of the negatives by finding a coterminal angle. So I'm going to add 12 pi over 6 here. When I do that, I get negative pi over 6. Now, I can do it again to get positive. I'm actually instead going to use the negative pi over 6 because that one's not so hard to work with. That's just going to be right down here. Now, that angle there is the negative pi over 6. Let's go ahead and draw our triangle. So now we're going to bring it up towards the x-axis. There's our reference angle. And I hope that this one's pretty easy for you to see, that the angle of reference here would just be pi over 6, and that's what we could use instead. Now the great thing about reference angles is that they allow us to use smaller angles that are always positive to find our answers. So that means we can use our basic unit circle. Let's go ahead now and see how these are used. So let's bring up our next slide. Oh, and I'm sorry. First, let's do your multiple choice question. I want you to find the angle of reference for negative 150 degrees. Once you're done with that, we'll go on to the last objective and the last slide, where we're going to see how to use these. Now, at the top it says the values of trig functions at any angle are the same as the value of the functions at its reference angle. But the signs, meaning the positive or negativity, could change. So basically, you can answer any question with using the reference angle instead. The only thing you have to think about is should my answer be positive or negative? So if I look at the first one, the sine of 135 degrees. Now, many of you right now are going to go to your unit circle, you're going to look for 135 degrees, and you're going to look at the y value. And that's okay. You'll see in a second we're going to get the same answer. Instead, though, let's see how the reference angle can help us. The reference angle for 135 degrees, 135 degrees is right here in quadrant 2. The angle of reference would be this angle right inside here. Now if I take 180 degrees and I subtract 135, I can see my angle of reference is 45 degrees. Now that means that I can use 45 degrees instead of 135 to find my answer. The nice thing is that if you have your quadrant 1 points memorized, you don't even have to think about the picture. You could just think about 45 degrees. You know that 45 degrees, the sine of that is root 2 over 2 in quadrant 1. The key here, though, is that we're in quadrant 2. 135 degrees would be in quadrant 2. And so in quadrant 2, sine is positive, so it looks like we can leave this as positive. And our answer would still be root 2 over 2. Basically, all we did is used a smaller angle, 45, to come up with our answer instead of 135 degrees. The next one, 4 pi over 3. Now, 4 pi over 3, and let's try this for a minute without the picture to see really how these reference angles could be helpful. 4 pi over 3 would be in quadrant 3. Now, in quadrant 3, you have to remember that cosine is going to be negative. So right away, I know my answer is going to have to be negative. And now let's think about angles of reference. Since I'm in quadrant 3, I'm going to take halfway around, I'm going to take the amount I have, 4 pi over 3, and subtract halfway around the circle, 3 pi over 3. And I'm going to use pi over 3 instead. Now, in quadrant 1, pi over 3, the x value at pi over 3 is 1/2. So that tells me the answer here will be negative 1/2. We'll look at the picture now to help, just in case. So if we look at the picture for a moment, we had 4 pi over 3, and 4 pi over 3 is down here in quadrant 2. When I bring this one up, you can see we're going to take pi, 3 pi over 3, and subtract that from 4 pi over 3. And that's where we got that pi over 3 reference angle. And then we looked at quadrant 1 at cosine of pi over 3 to get the 1/2, but we made it negative because cosine is negative in quadrant 3. Your free response question is to find the tangent of 14 pi over 3 using reference angles. So I really want you to try to use these reference angles, and this is where we'll end our video for today.